This tutorial will go through a few more complex fractions problems, which is the last topic in section 6. So here's just a few more examples if you need a little bit more help to see what's going on. Alright, so our first example is going to be 1 plus x 1 over x plus 1 over y over 1 over x minus 1 over y. So the reason it's a complex fraction is because there's fractions on the top and the bottom of the fraction. It's like a fraction within a fraction. And what we want to do is we want to find the common denominator, the least common denominator of every single term. So we've got xy, xy. The thing that would get rid of all of those for us would be just an x times a y. So we are going to multiply every single term by x times y. So when I go and multiply 1 over x times xy, I'm going to be left with just a y on top. When I multiply x times y times 1 over y, I'm going to be left with just an x divided by, on the bottom, when I distribute this xy to that x, 1 over x there, I just have a y on top. And when this xy goes to 1 over y there, I just have an x on top. Right? If I could simplify this any further, I would. If it was a quadratic that needed to be factored or something, but that is as much as I can do. Let me just go back for a second to what happens here. When I distribute this, if I have 1 over x plus 1 over y, and I'm multiplying that whole thing by xy, so that xy goes to my first term, 1 over x times xy, and those x's cancel, which is how I'm left with just a y, and then the same thing happens with the 1 over y, just to make that clear. Okay? So that's the basic idea there. I'm going to do a few more examples. Example number 2 is going to look like this. 2a over a minus 1 minus 3 over a all over 1 over a minus 1 plus 2 over a. So the first thing we need to do is look at all of our denominators. A minus 1, a minus 1, a, and create the least common denominator, which is all of those combined minus any duplicates. So I'm going to have 1a and then 1a minus 1. And that is what I'm going to multiply both the top and the bottom by. Alright, so I'm going to erase this. So I can write this clearer up here. So the top is going to get multiplied by a times a minus 1. So is the bottom. Because this is the same as multiplying by 1. Because a times a minus 1 over itself is 1. Alright, so let's distribute this across the top. When I multiply that first fraction by a times a minus 1, you see how the a minus 1s are going to cancel? I'm going to be left with 2a squared. Then when I multiply this to the 3 over a, the a's are going to cancel. I'm left with minus 3 times a minus 1. Alright, and then on the bottom, same thing, distribute this whole guy to this thing, and the a minus 1s are going to cancel, and I'm left with just a, because it's 1 times a. Now I start over, and I distribute this whole thing to this term, and the a's are going to cancel, and it's plus 2a minus 1. So now I need to distribute, or simplify this guy, and I've got distribution to do on the top and the bottom. So I need to, alright, so I'm going to try to write as small as I can up here. Ooh, oh hello, I can do that, okay. So now, this is going to equal, I've still got 2a squared on the top, minus 3a, and then remember I'm distributing a negative 3, so negative 3 times negative 1 is a positive 3, all across the top. On the bottom, an a plus a 2a, and then minus 2. Alright, so we're almost there. On the bottom, I've got 3a minus 2, and I combine all my terms. Can I factor this 2a squared minus 3a plus 3? If I could, I need to find something that multiplied to 6 and added to negative 3. And it turns out there is not a combination of two numbers that does that. So this guy is my final answer. Alright, I'm going to do one more quick example. Alright, last example is going to start out looking a little different. On the top, we've got a minus a to the negative first over a plus a to the negative first. But what do we know about raising something to the negative first power? That's the same as the reciprocal of it. So a minus 1 over a plus 1 over a. Alright, now look at all of our denominators. We got nothing there, which is just a 1. We've got an a there, a 1 there, and an a there. So our LCD, least common denominator, is going to be 1 times a, which is just a. So I'm going to multiply the top by a and the bottom by a. Alright, let's do a lot of distribution here. So distribute this a to that a over 1, which is going to be a squared, minus, now when I go to distribute this here, they're actually going to cancel. So I just got a squared minus 1 on the top. Then, on the bottom, distribute that a squared again. And then distribute that to this one. The a's are going to cancel again, and I've got a squared plus 1. We can factor this a little bit, but nothing is going to cancel for us. A squared minus 1 factors into a minus 1a plus 1 because the ones add to 0 and multiply to negative 1. But in the bottom, we don't have two numbers that multiply to positive 1 and add to 0. So the bottom just has to stay the same. And this guy is our final answer.